Our growth topic is about the downstream matter in the demands for money. This study examined how export activities, as a core element of international trade, influence the demands for money in an open economy. Today, with more trade restriction and global uncertainty, it's important to understand how trade affects money demand to make the better economic policies. We know that traditional model of money demands emphasize the role of real income and the opportunity cost of holding money, commonly measured by interest rate or inflation. However, these models are often framed in the context of closed economic tend, and tend to overlook the effect of international trade. In an open economy like Malaysia, exports are a significant source of liquidity. Exports earning enter the financial system are covered into local currencies and support an increased level of consumption and investment. This process increases the transactional need for money. Trade-related policies, such as tariff adjustment or opening measure, further influence money demand by changing the scale and the structure of economic activity. Therefore, in economic where the exports plays a central role, trade follow should be considered a potential determinant of money demand. The goal of this study is to find out if export activity has long-term effects on the demands for money in Malaysia. We use the really export expenditure as a key variable and apply the ARDL model to test its impacts on border money demand known as M2. The idea is simple. More exports means more income, which leads to greater need for money in the economy. If this link is confirmed, it shows that three factors should be included in how we move and manage money demands in open economics. Earlier model of money demands often focus only on domestic factors like income and interest rates. But in open economics, external trade, especially export, also plays a major role. Exports earning increase the liquidity and supports higher spending, which raises the demands for money. Although, instead of using total GDP, breaking it into parts like exports giving a more clear picture of what drives money demand. Many studies on developing countries show that including exports data improve both the accuracy and the stability of money demand models.
Hello everyone, my name is Nugraha Bin Sentosa and I'll be doing the methodology sections. So the first part of the methodology is the data and variables. The data that we gathered is the annual data from the year of 1980 to 2023. The sources that we gather this data from is the World Development Indicators by the World Bank. And for our model, the independent variables is the real money demand, which is the nominal M2 aggregate. It is deflated by the CPI, and we take the year 1980 as the base year. We have 5 independent variables, which are the final consumption expenditure, investment and expenditure, export expenditure, official exchange rate, and lastly, the deposit interest rate. The four first independent variables, except the deposit interest rate, are deflated by the year 1980 as a base year. Let's move on to the second part of the methodology section. For our econometric model, we use the augmented money demand function based on Tang 2007 and previous studies related to monetary theory. Uh, Most of our variables are in their logarithmic forms in order to capture long-run dynamics. You can see our variables in the slides. There are also several testing that we used. The first testing is the stationarity testing, which comprise of the ADF and KPSS unit root tests. Many time series variables in economics are non-stationary, meaning their statistical properties like their mean and variance changes over time. We use both because they complement each other such that if ADF fails to reject and KPSS rejects, then it strongly suggests that variables are non-stationary. If ADF rejects and KPSS fails to reject, then it strongly suggests stationarity. The next test that we use is the co-integration testing, which is the RDL bound test F statistics. So let's say even if individual variables are non-stationary in the integrated order of 1, I1, they can have a stable long-run relationship if they are co-integrated. If variables are co-integrated, they tend to move together in the long run, even if they deviate from each other in the short run. The purpose of the RDL bound test is to identify whether a long-run co-integration relationship exists among these variables. Next, we use the diagnostic test residuals. So in econometrics model, they rely on certain assumptions about the error terms residuals for the estimated coefficient to be efficient, unbiased, and for hypothesis tests to be valid. Violations of these assumptions can lead to incorrect inferences and unreliable forecasts. Non-significant p-values is the desired because it indicates that we cannot reject the null hypothesis, such that there would be no heteroscedasticity or no autocorrelations. We use stability tests, the QSUM and QSUM square, for economic relationship, as we know, that are not always constant over time. There always happen to have structural breaks, such that policy changes, economic crisis, and so on. These breaks can cause model parameters to change. So we use this to confirm that the estimated coefficient are stable over the sample period, meaning the relationship are consistent. Lastly, we use the Granger causality test. In time series, it's common for variables to move together without one truly causing the other. The purpose of the Granger causality test is to determine if past values of one variable, in our case is the exports, let's say, prove statistically that there is significant information for predicting future values of another variable, which is the demand function, money demand functions, even after accounting for the past values of money demand itself. I'll pass on to the next part on the analysis to the next presenter. Thank you.
The aim of our study is to investigate whether export expenditure has a significant effect on Malaysia's M2, both in the long run and short run. We begin with a descriptive analysis to understand the patterns in our data. From the time series plot, we can see that most variables, especially M2 and exports, show stronger upward trends. DIR shows sharper fluctuations in the 1980s and again during the 1997 to 1998 Asian financial crisis, reflecting major policy shifts. Our correlation analysis also shows stronger positive relationship between M2 and the income components, export, consumption, and investment, all above 0.93. This supports the theoretical expectations that increased economic activity lead to higher money demand. We then conducted ADF and KPSS unit root tests. The ADF test, which assumes non-stationarities under the null hypothesis, and the KPSS test, which assumes stationarities under the null, both confirm that all variables are integrated of I1. These consistent results validate the use of the ARDL approach for modeling the long-run relationship. The bond test produced an F statistics of 12.57, which exceeds the 1% upper critical bound. This confirms the existence of a long-run co-integrating relationship among the variables, allowing us to proceed with estimating the ARDL model. As a next step, we estimated the long-run relationship. In the long-run estimation, we found that export expenditures has a positive and significant impact on M2, with a coefficient of 0.49, significant at the 1% level. This means that a 1% increase in real export is associated with a 0.49% increase in real money demand. These results confirm that exports are a key long-run determinant of monetary demand in an open economy like Malaysia. Other variables such as EIG and DIR are marginally significant at the 10% level, and their signs align with economic theory. In the short run, we observe a notable dynamic effects of export activity. Though the signs of export lags are negative, possibly due to short-term liquidity movements or delayed export settlement. The error correction term is significant and negative, with a coefficient of negative 1.008, indicating rapid adjustments toward long-run equilibrium. The world highest confirms that the joint short-run effect of export lag is statistically significant. Finally, we check the stability of ARDR model using the CUSUM and CUSUM of square test. In both charts, the test lines remains well within the 5% confidence bound, which indicates that the estimated parameters are stable throughout the sample period. In addition to those diagnostic checks, we also run a granular causality test to see whether changes in exports can have predicted changes in money demand, and the result shows a one-way causality running from exports to M2. This supports that we have found earlier and further highlights the trade, especially export activities, plays an important role in shaping Malaysia's monetary environment. To conclude, we find stronger empirical evidence that exports significantly and positively affect money demand in Malaysia in the long run. Short-run dynamics and causality patterns further highlight the relevance of trade in monetary behavior. In today's volatile trade environment, shaped by tariff and geopolitical tensions, understanding the impact of trade on money demand is more important than ever. Policymakers in open economies must consider trade-induced monetary effects when designing inflation targeting, liquidity control, and broader monetary strategy. Better coordination between trade and monetary authorities can enhance the effectiveness of macroeconomic management. So, does trade matter in the demand for money? Based on our results, the answer is yes, and it should be considered in future monetary policy design. Thank you.